questions, as you said, right? We
Yes.
can discuss important formula questions, important concepts and all, right? We can do that if you want in that way. Yes.
Sir.
I think this we have discussed, right, with you. Question do we have? We have started from electric charge, right? In
Yes,
our
sir.
class. Okay, okay. So 1 month means up to this December end, right?
Yes, sir. We have vacation till December 26th.
Okay, okay. December 20. No issues. We can do that. So, what was the last topic which we have discussed? I think we were discussing the charging, right? Method of charging and all we have discussed.
Yes, yes.
Can you check your notes?
Yes, sir.
This was distribution of charge we have discussed, and then we have done some questions also, I think.
Yes.
Okay. So we can practice for concept point of view, we can do. So what we will plan, what we will do is, uh, we can do the important formula, okay, which is important and important concepts only, and then we can do the questions. And if you see, there are like number of 15 chapters in class 12, right?
Yes, sir.
So we will not have, if we exclude Sundays and all, so uh, like on an average we can put uh, 2 classes per chapter, right?
Yes, sir.
In that way we can do, right?
Yes.
Okay, all right, okay, no issues. So do you have what is your experience from the last class? Do you had any doubt in understanding, any kind of feedback? If you want to share, then we can start in that.
So I don't have basic knowledge, so I think it'll be difficult to cover everything in 1 month. So
Yeah, basic thing that will be okay, and which are actually uh, you will not need some uh, prior kind of uh, like, obviously the things are connected, but it can be manageable. I will, if there is anything related to previous concepts or from the previous classes, I will dictate you how
okay,
the
sir.
things go on. That is not be an issue. And generally students facing problem in mathematical things, but if you're focusing class 12 only, then not much mathematical expressions or understanding required. So we can do, if some kind of expressions come which is related to previous classes or mathematical expression, so I will explain you whenever those things will be used. Getting my point? Like if you're we are using differentiation kind of thing, I will explain you what is it.
Okay, sir.
Generally not much required. At some places we will need to have idea of differentiation, that is new for a student, so that I will explain. Apart from that, the things are normal basic concepts are required which you can understand. That will not an issue. And you can ask me if you need doubt, you will have during the lecture, you can ask me at that point of time. No hesitation, you can directly ask me. I will explain you. Getting my point?
Yes, sir.
So that is the thing. So shall we go ahead?
Sure, sir.
Okay. So what was the last? Can you say what was the last point which we have discussed?
We were asking question, sir.
What was the? We were doing questions.
Yeah, three identical conductors A, B, C. That question.
Oh, that question we were doing. Okay. Three identical conductors. And that question I have written there, right?
Yes, sir.
Okay, okay. So have you tried that question?
Yes, sir. We discussed the answer and ended the class that day.
Okay, okay. So method of charging we have discussed, right?
Yes, sir.
Okay, okay. Now we will come directly to the Coulomb's law. That is very important part of the chapter. Coulomb's law we have not discussed, right?
No, sir.
Alright. So we'll start with Coulomb's law. That is very important and basic of electrostatic, you can say, and not much difficult. So what is your class duration? You need
Tuition,
class duration.
meaning this class.
I mean class duration means you want 1.5 hour class, 1 hour class.
Anything is fine, sir.
Okay, okay. So I think 1.5 hour class will be okay. We don't have much time.
Yes, sir. Sure.
Yeah, yeah. All right. So starting with the Coulomb's law, like it is about, it is basically about force between 2 point charges. Like according to this law, suppose we have 2 point charges. Like we have 2 point charges Q1 and Q2, and these charges are separated by distance r. Suppose the separation between the charges is r. So according to Coulomb's law, force, and these charges are point charges, right? These are point charges.
Yes, sir.
These are point charges. So according to Coulomb's law, the force between these 2 point charges F is proportional to product of charges, right?
Yes, sir.
And inversely proportional to square of distance between them, right? So
Yes, sir.
Coulomb's, according to Coulomb's law, have you same as the Newton's law of gravitation? We
Mm,
have seen in Newton's law of gravitation that the force between two masses is proportional to the product of masses and inversely proportional to square of distance between them. Same is the case with the Coulomb's law. Force is directly proportional to product of charges and inversely proportional to square of distance.
okay,
And
sir.
the force is given by F equal to K Q1 Q2 by R square, where basically we write K is, where K is a constant, where K is a constant, and can also be written as 1 by 4 pi epsilon naught Q1 Q2 by R square. So this is the formula, and where epsilon naught is basically called permittivity. It is called permittivity of free space. and its value is actually 8.85 into 10 to the power minus 12 Newton meter square per coulomb square. 8.85 into 10 power minus 12 Newton meter square per coulomb square.
Okay.
That is, it is known as epsilon naught. You can pronounce it at epsilon naught. Epsilon. So this is the thing, and if we calculate 1 by 4 pi epsilon naught, so that will come out to be, if you put the value of pi is 3.14 and epsilon naught is 8.85 into 10 to the power minus 12, we will get approximate value as 9 into 10 to the power 9, and what will be unit of that? We have 1 by 4 pi epsilon naught q1 q2 by r square, right? So what will be unit of 1 by 4 pi epsilon naught? Can you tell?
Same as permittivity.
Unit of 1 by 4 pi epsilon naught. What will be unit of that? We are calculating here 1 by 4 pi epsilon, right?
Newton inverse, meter inverse, c square.
Newton
Inverse,
by inverse.
because it's 1 by.
Yes, so assume it is as a constant k. Getting my point? So it is k q1. So you want unit of k only. You can derive unit from this formula. Getting my point?
Yes,
Or
sir.
from this formula also. So yes, from here if you want to, this is the unit of epsilon naught, right?
Yes.
Newton meters per coulomb square. So 1 by 4 pi epsilon naught will be equal to reverse of that, right?
Yes, sir. That's what I said. Hello.
Yes, are you getting my voice?
Yes, sir. Yes. Sir, so
Sorry.
it's Newton inverse, meter inverse to.
No, actually, sorry, there is a mistake in this unit. It should not be that. If we are taking epsilon naught unit, it will be equal to, getting my point, it will be equal to coulomb square per Newton meters. Coulomb square per Newton meter. If you see here, we are taking unit of epsilon naught, right?
Yes, sir.
So epsilon naught will come there. Like, from here what we can write? We can write epsilon naught is proportional to basically q is q1 q2 by f r square, right? So from here we will get this unit. Got it?
Yes, sir.
So now you can take inverse. So that will be Newton meter square per
Right.
coulomb square. Got it?
Yes, sir.
So its unit will be Newton.
Newton square by c square.
Got it?
Yes, sir.
So same method, just we have to cross multiply corresponding units. So now we know that. So the main thing is force is k q1 q2 by r square 1 by 4 pi epsilon naught q1 q2 r square. This is only in air. 1 by 4 pi epsilon naught will be in air, and for positive charges we know that like charges,
Attract. No, repel and unlike charges attract.
correct, right charges repel and unlike charges. So this is the thing. Now what will happen? The force is always along the line joining the charges. Suppose the force exerted on Q2, the force exerted on Q2 by Q1 will be along this line, and force exerted on Q1 by Q2 will be along this line, along the line joining the charges. Force is always along the line joining the charges. Got it?
Yes, sir.
Any doubt in this?
No, sir.
And this is only for 1 by 4 pi epsilon naught is for air only. Getting my point?
Yes,
If
sir.
there is a medium, if there is a medium, if there is a medium, now suppose the charges are placed in a medium, so in that case, suppose charges are Q1, Q2, and these are placed in a medium. And so in that case, we will define F equal to K Q1 Q2 by R square, where K will be equal to 1 by 4 pi epsilon. In here it was epsilon naught, now it is epsilon, where epsilon will be equal to epsilon naught into epsilon R. And epsilon R is known as relative permittivity.
Okay, sir.
It is known as relative permittivity.
Sir, this is the equation for if force, no, the charge is on another medium than air.
Yes, yes, yes.
Okay, sir.
Another medium than air. Like in metal, like in any can be. Medium can be any dielectric. Getting my point?
Yes, sir.
So the epsilon R value will be given in the question. Epsilon R value ranges like 4, 5, 6, 80 kind of thing. It is given in the question. It will be given in the question. We can. Got it?
Yes, sir.
So let us do some questions based on Coulomb's law. Then we will move ahead. So we can do some neat questions, previous year questions. So let us see question number 1. Can you try question number 1?
Yes, sir. Sir, I don't know.
Let us see. Suppose we have 2-point charges A and B. There are 2-point charges A and B. We have 2-point charges A and B. A and B, and having charges plus Q and minus Q, and are placed at a certain distance apart, and force acting, suppose the distance between the charges is suppose R, certain distance apart, and force acting between them is F. So what will be the force in this case? That will be equal to Q square by R square, right?
Yes, sir.
Now if 25% of charge of A is transferred to B, now what happens? 25% means, what is 25%?
25 by 100.
It means Q by 4. So Q by 4 charge is transferred from here to here, right?
Yes, sir.
So what will be the new charge now? Q minus Q by 4. So it will have 3Q by 4. And
Yes,
what will we charge on this? Minus Q plus Q by 4. So it will be
4 by 3, 4.
minus 3Q by 4. Got it?
Okay, sir.
Minus 3Q by 4. Understood this one? How minus 4Q by 3? Minus 3Q by 4. Got it?
Yes,
So now we can calculate the force, right? What will be the force? New force F dash 3Q by 4 into 3Q by 4 divided by R square. Distance is same. So 9 by 16, and K will be also there. So 9 by 16 into KQ square by R square, right?
yes, sir.
So it will be 9 by 16 F. F is KQ by R square. Got it?
Yes, sir.
The correct answer will be. So this is how we can proceed. This is NEET 2019 question. Is it tough?
Kind of, sir.
Not tough means we have to think a little bit. They will not give the straightforward question
Okay,
like
sir.
find the force between two 1 coulomb charges placed at 1 meter. There will be some twist in the question, but if you can do practice, we can do it. Got it?
Yes, sir.
All right.
Sir, 1 minute. I didn't complete the answer.
You want to write?
Yes, sir. Done.
Right. Sometimes also we write Coulomb's line vector form. Like that is not much required, but you can write it like suppose vector form of Coulomb's law. So if you want to write vector form, like suppose we have two charges q1 and q2 separated by distance r. So in that case, we know that what is f? F is equal to k q1 q2 by r square. So this is scalar form. If you want to write in vector form, we can also write it like this: f equal to k q1 q2 by r square, r unit vector we have to put. Getting my point?
Yes, sir.
So k q1 q. What is the definition of unit vector? Unit vector, like suppose you want to find a unit vector, so we define it like this: the vector divided by its magnitude. It's
Okay, sir.
called unit vector. If you want to find any unit vector along a given vector, just divide by its magnitude. And it seems obvious, right? If you divide any vector by its magnitude itself, then what will be remaining? 1.
Yes, sir.
So that is the thing. So here you can write r unit vector means r vector divided by mod r. So it will be k1 q2 by mod r equal to r. We know that if we are taking mod of any vector, it is simply that one. So it will become rq. Got it?
Yes, sir.
So this is the vector. It is not required, just generally it is not required. After this you will not require vector form anyway. But sometimes in board exam they may ask question like, so you have to understand. In numerical, no use of kind of vector. So there was a question like you can see question number 9, it is in vector form. So you can attempt this one, question number 9.
Sir, A.
So you got A. Let us check. So it says an electron is moving around a nucleus of hydrogen. So we know that nucleus is basically at the center, and like an electron is revolving. You may have studied in chemistry also, like
Yes, sir.
electron revolves along the nucleus. Suppose the distance is r, then Coulomb force between the two is. So basically what will happen, suppose so here we know the what is vector form. Vector form is basically, as I have given you the formula, you can directly use that k q1 q2 by rq, right? R.
Yes, sir.
But here we have to see one thing. R means r vector. So suppose I am taking this as origin, so r vector will be like this. So here, if we take q1 equal to q2 equal to e in the formula,
Okay, sir.
so what will happen?
E
K
square.
e square by r cube into r. But suppose this is negative charge, electron is negative charge, and nucleus is positive charge. So according to this formula, force will be along this direction, because R is from origin to along x-axis. Getting my point?
Yes, sir.
The force will be away from the nucleus. That is not true. We know that this one charge is positive, one charge is negative. So force will be attractive.
Yes,
Getting my
sir.
point?
Yes, sir.
So the direction must be equal to along minus R. Getting my point?
Yes,
So
sir.
here we have to keep in mind sign also. You have to put one is plus E positive and then minus E.
Okay,
Getting
sir.
my point? So
Yes.
then answer will become C. You always remember that if the force is negative, if charges are of opposite nature, then force must be given with negative sign. Getting my point?
Yes, sir.
Not C, it should be D. Got it? Minus
Yes.
R, not R unit vector, R. So there must be a negative sign if the charges are of opposite nature. Got it?
Yes, sir.
So this was about Coulomb's law. Let us do one last question based on Coulomb's law, then we will. Sometimes like we get question like this. Uh, suppose we have two charges like plus Q and minus like 4Q, right?
Yes,
And you
sir.
have to find location of a point. You have to find location, find find the location, find the location where a third charge should be placed such that no force acts on it, such that no force acts on it. So we have to find the location of a point where a third charge should be placed, such that no force acts on it.
Yes, sir.
So such type of question generally asked sometimes. So what we will do is, let us see. We have to analyze that. If you consider a point in the middle, so is it possible that if the point is in the middle, total force will be zero? We have to consider the force due to both the charges. Getting my point?
Yes, sir.
Suppose the point P is here. So what will happen here? Q is positive charge. Suppose this is charge Q naught is positive. So what will happen? Due to positive charge, force will be towards right. Got it? It will
Yes.
repel. And due to negative charge also, force will be towards right, because negative charge will attract.
Yes.
Got it? So
Yes,
if
sir.
the point is in between the charges, both the force will add. Therefore, the location cannot be between the charges. Got it?
Okay. Yes, sir.
Now the possibilities are here and here. Now suppose the point is here. Suppose the point P is here. What will happen now? Force will be opposite. due to both the charges. Due to positive charges, it will be like here, and due to negative charge, it will be in this direction.
Yes.
Got it?
Yes, sir.
If you see here, point P is here, then again, due to positive charges, due to positive charge, force will be towards this direction, and due to negative charge, force will be towards this direction. So both the positions are possible,
Yes.
but which one is the correct position? How we will decide? Both cannot be the position, so we have to decide one position in between the two.
Yes, sir.
Middle position cannot be the position, so we have discarded that. Now
Okay.
two possibilities are possible: left side, either left side or right side. So how we will decide between left and right? You have to see the, forces should be equal, right?
Yes, sir.
Then and only then force can be zero. If you see the location 1 here, suppose this is location 1, so it is closer to the greater charge. Getting my point? Minus 4q is greater charge, so it is closer to the greater charge, and we know that F is proportional to charge and inversely proportional to
Read.
square of distance. So if it will be close to the charge, then force of minus 4q will be obviously more than due to plus q,
Yes, yes.
because charge is more and distance is also less. So is this position possible? Right side position?
No.
No, because it cannot be closer to greater charge. It must be away from the greater charge.
Yes,
Then
sir.
force of both the charges can balance. Got it?
Yes, sir.
So one is also not possible. So the correct position is left side of a smaller charge. Now we can find the force. Suppose it is at a distance x from the smaller charge. Getting? So
Yes,
what we will do? We will equate the force. We can equate the force like the force due to plus charge should be equal to force due to minus charge,
sir.
and we can put q naught. I suppose it is a distance x square, that should be equal to k 4q into q naught by r plus x square, right?
Yes, sir.
Because this distance is r, so from 4q the distance will be r plus x. So from here we can calculate x, right?
Yes, sir.
From this we can calculate the value of x. Got it?
Yes, sir. Understood.
So this is how we can decide the location of a charge.
Okay, sir.
So this was all about Coulomb's law and forces due to different charges. Moving to the next concept, that is electric field lines. So any electric field. Any doubt till now?
No, sir.
All right. One more thing, like if you want to find force due to a spherical charges, right? Now we have studied about point charges only. But
Yes.
suppose if you want to find force due to spherical charges, suppose these are having charges q1 and q2, and if you the distance between their centers is r. So in that case also you can assume these charges are point charges placed at their centers. Getting my point?
Yes, sir.
These can be considered as due to spherical, in this case of spherical charges only, in not all cases. Like if you want to find the force between a charged rod and a cube. Getting my point?
Yes, sir.
So in that case you cannot assume these charges at the center. These are not symmetric configuration. Getting my
Okay, sir.
point? So
Yes.
in case of spherical charges only, we can consider the point charges are placed at,
Center.
you can assume the spherical charges are point charges and placed at their center. So the force will be same as point charges, A Q1 Q2 by R. Got it?
Yes, sir.
So this is the case with the spherical charges placed at their center. All right. Moving to the next topic, there is also comes in between like principle of superposition, that is obvious. Like if you have many charges there, and if you want to find the force on a single charge due to all the charges, so what we will do, we will add vectorially.
Okay, sir.
Getting my point? With
Yes, sir.
number of forces acting, so it is seems to be obvious. If you want, no need to give it a separate law, but at that time it has been given. So net force, how we will find, we will take vector sum of all the forces. This is called principle of superposition. So this seems to be true, right? This seems obvious. If there are number of charges present, then how we will find total force? We will take vector sum of all the forces.
Okay, sir.
Got it?
Yes, sir.
Let us take one example for that. Suppose we have like triangular configuration like this, and suppose we have charges like we have plus q, we have plus q minus. Suppose it is an equilateral triangle and the charges are placed on the vertices A, B, and C as shown in the figure. We will
Yes.
assume it is as equilateral triangle. So here we can apply the principle of superposition. So if you want to find the force on charge placed at C, right? So
Yes,
how we
sir.
will find? We'll take the vector sum of all the forces. Like here we will see the force due to plus charge will be along this line, right?
Yes, sir.
And the force due to plus charge here will be along this line, this line. So we have to take resultant force, right? Suppose,
Yes.
and from the symmetry of the figure we can say that if A equal to FB, right?
Yes, sir.
Because distance is same, charges are same,
Yes,
so
sir.
magnitude of A and V will equal. Suppose it is F. So how we will find the resultant force? You can use the vector formula. You know the resultant formula for vector, what is that? A square. What is the resultant formula for two vector A and B? A square plus B square plus 2AB cos theta. You might have, if you remember that.
Yes, sir.
If there are two vectors A and B inclined at an angle theta, then the resultant vector is given by under root A square plus B square plus 2AB cos theta. You know this formula?
Yes, sir.
So we can apply here same for resultant F square Both forces are equal, right? F square plus F square plus 2ab, 2F into F. And what is the angle between the forces?
Cos theta. Cos 60.
Correct, it will be 60 degree. So you will get it as F square plus F square plus 2F square into cos 60 is half, right?
Yes, sir.
So it will be equal to 2F square plus F square. So we will get it as under root 3F square. So we will get it as root 3F. And what will be the value of F? What is the value of F?
Um, 1 by 4 pi epsilon 0. Q1 Q2 by R square.
Yes, 1 by 4 pi epsilon naught. Q1 Q2 means Q square by
Sir.
A
Yes.
square, right?
Yes,
F
sir.
will be basically equal to 1 by 4 pi epsilon naught Q square by A square. Got it? The distance between. So this is the resultant force. And obviously, if the forces are equal, the resultant will divide both the charges, right? Both
Yes,
the
sir.
force. So it will be along the divider line. It will go along like this. And the angle of resultant will be, what will be the angle of resultant? With BC, it will divide the angle. So this angle will be 30 degree.
Yes, sir.
If the forces are equal. Got it?
Yes, sir. Done, sir.
No. So this was the force due to multiple charges. Now moving to the next topic, that is electric field. So we know that how we will define electric field.
It is the area where it is a region where the presence of electricity is felt.
Yes, kind of. Suppose you have a charge Q. Getting my point?
Yes, sir.
So electric field is basically the effect of a charge in a region. You have seen a spider, right? You
Yes,
have
sir.
seen a spider. They have their own, like, kind of net, what we can say,
Yes, sir.
their own net around the region, right? So
Yes.
that kind of, so in that region, in that area of the uh, spider, if any insect comes, it catches that. The same kind of thing is here.
Yes, sir.
The electric field is having its influence in the region. It
Oh,
acts like its hands and legs. Getting my point?
yes, sir.
Electric field acts as hands and legs in the region, and if any charge comes in the region, it will exert force on that charge. If
Okay.
any charge come in this region of the field, it will exert force on that. So suppose we have any charge q naught in the region, and suppose it this charge q exerts force F on this charge q naught. What am I point? From
Yes, sir.
Coulomb's law, it will exert force. So we defined electric field as electric field E as force per unit charge, F by q naught. We define electric field as force per unit charge.
Okay, sir.
Got it?
Yes, sir.
Let me check once. Is there any other class schedule? So for today, they are saying end class at 7:30. All right.
Okay, sir.
So I think it is scheduled to for today. It is scheduled for 1 hour, but next time onward, we will schedule it for one and a half hour. Okay.
Oh,
I'm ending here for today's class. Any doubt till now?
no, sir.
Okay.
Sir,
All right.
and also after this